All right, today we're going to break down a really groundbreaking paper that asks a massive question in AI. When a machine can write just like a human, how do we actually hold it accountable? This is the story of the quest for a digital fingerprint for large language models.
It seems like a simple question, doesn't it? But, in the age of AI, the answer is getting a lot more complicated. In this research, it directly confronts that growing uncertainty. It asks, how can we really know if we're reading something written by a person or by a program?
So, large language models, LLMs, they're just incredibly powerful. I mean, they can generate anything from a college essay to fully functional code. But that same power, well, it can be misused. As you can see with this simple letter swapping prompt, they can generate incredibly convincing synthetic text at a massive scale. And that's really where the trouble starts.
Before this research came along, we were really facing the problem of the undetectable AI ghostwriter. I mean, their work was pretty much impossible to tell apart from a human's, and that created some pretty significant risks.
And believe me, the stakes here are incredibly high. We're talking about everything from automated bots manipulating public opinion on social media, to the mass creation of fake news, to a whole new wave of academic plagiarism. And here's a really interesting one you might not have thought about. If the internet gets totally flooded with AI text, future AIs could end up training on that very data, which could create this weird feedback loop of just degrading quality.
So this brings us right to the central question these researchers were staring down. How in the world do you embed a digital fingerprint into AI text that's strong, that's reliable, and crucially, doesn't completely wreck the quality of the writing?
And the solution they came up with is just so elegant and powerful. They decided, hey, let's not just try to detect AI text after the fact. Instead, they wanted to build the signal right into the generation process itself. You can almost think of it like a secret color code that's hidden in the words.
This whole process is called watermarking. It's basically a hidden pattern that you and I would never ever notice just by reading it. But for an algorithm that's specifically looking for it, that pattern is a crystal clear, undeniable sign that the text was generated by a machine.
Now, what's really cool about this is just how simple their first idea was. Okay, so for every single word the AI is about to write, it just looks at the word that came right before it. And based on that one previous word, it secretly divides its entire vocabulary into two lists: a green list of words it's allowed to use and a red list of words that are forbidden. And then, it's just not allowed to pick anything from that red list. That's it.
And this is where the statistical magic happens. See, since those lists are created randomly, a human writer is going to naturally pick words from that green list about half the time, right? But the watermarked model, it picks them every single time. And that huge statistical difference is the whole key to detecting it.
But okay, there was a problem with this hard watermark. Having an absolute, unbreakable rule can sometimes make the text sound, well, bad. So the researchers came up with a much more refined approach, moving from a strict, hard rule to more of a gentle nudge.
This lays it out perfectly. The hard rule had a big flaw. I mean, what if the most natural next word, like Obama after Barack, happened to land on the red list? Forcing the AI to pick a different word would sound awful. The soft solution, though, is just genius. Instead of banning the red words, it just gives a tiny little score boost to the green words. It gently nudges the AI towards them, making them more likely but not mandatory. And that preserves the natural flow of the language.
So, the theory is really clever, but does it actually work in practice? Well, the researchers put this watermark to the test. And let me tell you, the results were pretty remarkable.
This quote from the paper really says it all. When they analyzed a watermarked piece of text, the chances of a human producing that exact pattern of green words was so ridiculously small, it's basically zero. It left them, and these are their words, extremely certain it was from a machine.
Of course, there's always a trade-off. As this chart shows, making the watermark stronger can have a small impact on the text quality, which is measured here by PPL, or perplexity. A higher PPL means lower quality. But the key takeaway here is that you can get a really strong, detectable signal with a quality drop so small that a human reader would probably never even notice.
And just look at these numbers. I mean, with the right settings, the system correctly identified AI text 100% of the time. But even more importantly, the false positive rate was 0. It never once, not once, falsely accused a human author of being a machine. And that is such a critical safeguard. And we come back to this number. This right here is the p-value. It represents the probability that the pattern of words they found could have been written by a human just by sheer random chance. A number this small is basically statistical proof. It's not just unlikely, for all intents and purposes, it's impossible.
So, problem solved, right? Well, not quite. The release of this technique actually kicked off a whole new phase in AI safety, a sort of arms race between watermarking and new, creative ways to try and remove it.
Yeah, this timeline really puts it into perspective. Before this paper, our detection methods were really struggling to keep up. This work introduced a powerful new defense, but as soon as it was out there, people started looking for weaknesses, and that led to the ongoing cat-and-mouse game we're still seeing today.
And boy, did people get creative. On the left, you're seeing what's called the emoji attack, where someone prompted the AI to stick an emoji after every single word. You can then just delete them, and that messes up the secret seed for the next word. On the right, a character substitution attack does something very similar. These are all just attempts to scramble that fingerprint.
So these attacks tend to fall into a few main categories. You've got people using another weaker AI to just paraphrase the text, hoping that'll wash out the watermark. Others make these tiny little changes like adding typos, or even using characters that look identical but are technically different. That's a homoglyph attack, all to trick the detection algorithm.
Which brings us to the final and most crucial question. This watermarking technique was a massive leap forward for accountability. No doubt about it. But as both AI and the attacks against it get more and more sophisticated, the challenge absolutely remains. The quest for a reliable digital fingerprint is more important than ever. And it forces us to ask, will we always be able to tell who or what is doing the writing?
This is for entertainment purposes only.